Hello, everybody. Last time we'd derived an equation that felt kind of circular because it had an x squared and a y squared equaling a constant. But either the x or the y or both were being multiplied by numbers, which we thought were maybe dilating the circle to make it into a stretched circle, which is an ellipse. We were right about that. But something that we glossed over, and I'm not sure everybody caught, was what effects does multiplying by 3 actually have? Kind of feels like it should be making the circle wider, because if you take x coordinates and you multiply them, the x coordinates are getting bigger, it seems like. So surely the circle is getting wider. And we're multiplying them by 3, so it seems like it should be getting wider by a factor of 3. In fact, no such thing happens. So let's figure out what does actually happen and why does it make sense. Let's set up a case that we can compare and contrast. And you can totally do this yourself, and not just for multiplying. You could do this for any transformation to think about why does the transformation do what it does. So I'm going to compare a case where we don't have any transformation at all to the case where we do have a transformation. And the question we're asking is, what effect does adding this times 3 have on the x values? So instead of thinking about all the x values, let's just choose a couple of convenient x values. So we know that this is a circle that's centered at the origin, whose radius is 4. So these x values should be at 4 and -4. But let's go through the actual calculation to see how does this equation end up giving you the x values. So if I want to solve for those x values, let's see, these are on the x-axis. So that's where y equals 0. So let's plug in y equals 0 and actually watch how the equation calculates those values. So if I plug in y equals 0, I have x squared plus 0 equals 16. And so that gives me that x, when I take the square root of both sides, that gives me x is plus or minus the square root of 16, which is 4. So there, no surprises yet. I have solved for two particularly salient x values. But the whole point is I want to know what happens for this calculation of the x values when I multiply by 3 over here. And the intuition I'd said, the wrong intuition I'd set up here, was it looks like the x values are getting multiplied by 3, and that's why they should be getting bigger. But of course, it's not clear like what we're multiplying by 3 here. Like if I wanted to say that the x values in my curve are all getting multiplied by 3, I would need to actually solve for the x values. So let's see what happens when we solve for the x values and what effect the 3 is actually having on that computation. So same thing. Let's choose, well, I'm not going to draw my circle yet because we don't know what it looks like yet. But let's choose the same y equals 0. So I want to see what happens to those two x values at 4 and -4. So I'm plugging in y equals 0. Now I've got 3x squared plus 0 equals 16. So now I'm solving for what are the x values. So this 3 that seemed like it was multiplying the x values, if I'm isolating x, it looks like what's actually happening is I've divided by the 3. Because remember, what's on the left-hand side is going to end up being our x value. Let's go ahead and solve it the rest of the way. So I'll take square root on both sides. Now I've got x is plus or minus the square root of this whole thing. Square root of the numerator is just going to be 4, and the square root of the denominator is root 3. Okay, so now time for the comparison. Here I had plus or minus 4. Here I have plus or minus 4 divided by something. So we can see that what appeared to be multiplying over here, in order to figure out what effect that's having on the x values, I have to solve for x, because that's the computation that actually tells me what x is. And when you solve for x, you have to undo all the steps that are kind of leading to x. So when I undo the multiplying by 3, that ends up dividing. And that shows me that what's really happening to the x values is whatever they were before, like 4, they're now actually getting divided by whatever that factor was. And in fact, they're not getting divided by that factor, they're getting divided by the square root of that factor, because to solve for x, we had to take the square root. So 4 divided by square root of 3 is going to end up making it narrower. It's some kind of contraction, and it's going to look approximately like this. And just to bring it on home here, where it appeared that we were making it wider by 3, what's actually happening is we're making it narrower by the square root of 3. So in order to make this style of reasoning feel more intuitive for you, here's something you can try. Try 2 more. Here I'm multiplying x by 3, but I'm not multiplying x squared by 3, I'm multiplying the x by 3 before I square it. And so now you might wonder, well, what's happening? Is this going to make it wider? Is it going to make it narrower by a factor of 3, by a factor of root 3, by a factor of something else? Try the same process. You can actually look to see by plugging in y equals 0, and then solving for yourself to see how does that multiplication by 3 actually affect the x values that you calculate. Same thing over here. What if I'm going to subtract 3 from x before I square it? What effect is that going to have on the x values if you isolate x to calculate what they are? Good luck.